Motorcycles are a widely utilized mode of transportation in today's world. Like every automobile, it combines a complex interplay of mechanical and electrical components engineered to work in harmony. A series of gears mounted on two shafts is the main component of the transmission system, which we will be covering in this video. Motorcycle riders use the gear shift lever to control the gear shift mechanism. The gear lever is linked to a star shift detent mechanism as shown in the animation. The star wheel is attached to a shift drum. The precisely machined grooves along its circumference accommodate shifting forks. These shifting forks are designed to accommodate gear dogs. Synchronized with the rotating shift drum, the shifting fork and gear dogs execute lateral movement. To understand the purpose of these sliding gear dogs, it is essential to analyze the gear arrangement within the transmission shafts. The gears are mounted on an input shaft and an output shaft. These shafts are segmented into splined and smooth sections. The splined section accommodates splined gears. It allows gears to slide laterally while also rotating with the shaft. Meanwhile, the non-splined section corresponds to freewheeling gears. It can spin independently on its axis, but it can't slide laterally. To ensure clear identification, let's distinguish splined and freewheeling gears using different colors. Also, please note that some gears have dog teeth which can slide into the freewheeling gear slots, which temporarily locks them. Since the setup is quite complicated, let's observe a simplified representation. A splined input gear is meshed with a freewheeling output gear. In this setup, spinning the input shaft will spin the freewheeling gear but not the output shaft. Now, let's introduce a splined gear which slides and locks inside the dog slots of the freewheeling gear. With this setup, rotating the input shaft will spin the output shaft, thus transferring power. Now, let's understand how this technique is used to achieve different gears. The model shown here illustrates a 6-speed transmission system. As we can see here, every splined gear is meshed to a freewheeling gear and no splined gear is locked. As we observed in the previous demonstration, there won't be any power transfer in this case. This is the neutral position of the motorcycle. To achieve first gear, the splined gear dog number 5 slides and locks to the first gear. To achieve second gear, gear number 5 slides to its neutral position and gear number 6 slides and locks to the second gear. A similar process is used to shift to third gear, the fourth gear, the fifth gear, and the sixth gear. Also, notice here that while shifting from one gear to another, the previously locked teeth slide back to a neutral position, and then the locking gear slides to the desired gear. This means there is a neutral position between each gear shift, which is undesirable. This is prevented by using the star shift detent mechanism we observed earlier. As we can see here, the star wheel consists of notches and peaks. Each position of the detent arm roller at the peak of the star corresponds to a neutral position, and each notch corresponds to an engaged condition. As we can see, the spring-biased roller cannot rest at the peak and rolls further to another gear, thus preventing neutral. Now, the only problem is that we can never achieve a neutral position even when we need it. To solve this problem, a peak of the star wheel is cut off, forming a neutral notch. Now, the roller can rest on this neutral notch, thus enabling us to achieve a neutral position where we need it. Applying further pressure to the gear lever will shift to another gear.